So our first example, we have f of x equals 3x minus 8, and we want to find the slope at the point 2, negative 2. We're going to use the definition of the slope of the tangent line to do this. So since I'm looking for it at a particular point, I can substitute that 2 in for the c value. So I have f of c plus h minus f of c. And really it's just simplifying this, and then we'll take the limit. So I'm going to distribute. Here I have 6 plus 3h minus 8 minus a negative 2. That's what I got of these parentheses here. So you see I have 6 minus 8 plus 2. All cancel out. I just have the 3h, and then the h's cancel. And I'm just left with 3. So if we go back and look at that original problem, if we think about this in terms of Algebra 1, it's obvious that the slope is going to be 3, and it's going to be 3 no matter where we look for it. So no matter what x value we want to find the slope, this is a line, it's a linear equation, linear function, so of course the slope is always 3. But we can see that using the definition of the tangent line, the slope of the tangent line, we can also find that. So now we're going to discuss the definition of the derivative. So this is one of the two fundamental operations in calculus. This is most of the first semester of our AB course, dealing with the derivative and its applications. And the derivative is just the slope of the tangent line. And there's lots of ways we can denote derivative, and we need to be familiar with all these different notations. So we could call it f prime of x. Sometimes we'll refer to that just as f prime. We can also refer to it as y prime. The way we denote the derivative is the derivative of y with respect to x. We could also say the derivative with respect to x of f of x. These are all just ways of saying the derivative. And in any of these cases, they're defined this way. They're a limit of the difference quotient. And again, we can use either h or delta x as a horizontal distance. So the derivative is the slope of the tangent line, either at a specific point or in general as a function of x. So here we have a new function, f of x is 1 minus x squared, and we're asked to find f prime of x and f prime of 2. So the derivative in general as a function of x, and then the slope at x equals 2. So again, it's the limit of the difference quotient. So we have 1 minus x plus h squared minus 1 minus x squared all over h. We're going to expand this binomial. So I'm going to have minus x squared plus 2xh plus h squared, all in parentheses. And then we have to distribute that negative sign. So we end up with a quotient that looks like this. And we can see here that we have 1 minus 1. We have negative x squared plus x squared. And both terms here left in the numerator have an h term that we can factor out. Then these h's cancel. And we're left with the limit of negative 2x minus h as h approaches 0. Now there's no quotient here, so there's no problem. We can just use this, solve this limit by substitution. Negative 2x minus 0 gives us that negative 2x. So that is f prime of x. That's the derivative. F prime of x is negative 2x. And if we want to find f prime of 2, just like with any other function, we plug in an x value of 2, and we get negative 4.